Alrighty guys, let's make a start. So, let's turn this down a little bit. My name's Stuart McDonald. Most of you guys probably knew me from shoots or pracs or whatever. So, the first 15 minutes of today, I'm just going to give you a brief outline of how this subject works. I know most of you guys did PTA last semester, but we do have some new cohorts that have joined us. We've got the dietetics students that have come in, as well as there are a few changes from PTA as well. So the stuff we'll go through in the next 10 minutes is important, and there are some differences you need to be aware of. So I'm the primary coordinator, Jared, who runs the prac subject, which many of you guys are doing and had your first prac today, or if you didn't know, you have your first prac today. He's the other coordinator as well. So if you can't get in touch with me, you can contact Jared. Textbook is the same you used last semester. It is different from last year's textbook. They do have copies in the bookshop. You can get them elsewhere as well. And yeah, most of the resources will come from that textbook, so you don't have to buy it, but I think the library has copies as well, so if you want to go in there for a read every now and then to catch up, it's an alternative to buying it. If you do buy it, you can always keep it, and obviously you can sell it on as well. Okay, in terms of the format of the subject, it's pretty much the same format to PTA. So we have 2 live lectures a week. In PTA, it was a bit messy. You sometimes had 3. In PTB, we just have 2, just Monday and Tuesday. So today, this venue, it's a bit small for the full cohort of students, but some of you don't turn up, so everyone tends to fit. And Tuesday, 2 to 3 as well. And most weeks we have some complementary online stuff. So there's online learning tasks, which if you are sort of up to date with the format of the first module, you'll see that we've already had some of those which you were supposed to have done before today's lecture. But John is aware that often people aren't aware of that until today, so he'll skim over some of that stuff, and then perhaps, following the lecture this afternoon or the next few days, you can review that stuff. So most weeks there's online learning tasks, and it's roughly 50 minutes per week. Some weeks, like this week, there's a bit, and other weeks there's not as much. Now the workshops are 1 hour, wrong class, 1 hour per week, so we don't have the messy ones like PTA. In PTA, in assessment weeks, you had those 2-hour tutorials. You don't have that for PTB. You do have to attend the workshop you're allocated to. If you're not aware which one you've been allocated to, check your allocate timetable. At the moment, all of them are full, so we have 9 groups, and we've actually, because they're full, we've had a few more enrolments than we expected. We've created a new class, so that's, unfortunately I haven't given it a letter, that's the unnamed hyphen class, which is at 2 o'clock on Thursday. So I'm getting a lot of emails from students asking to swap around. Because all of the classes except for that one are full, it's pretty hard for me to swap people unless they have someone to swap with. So what I'm suggesting, if you really do need to swap, and you can do the Thursday 2 o'clock class, that you perhaps ask your group or someone in that class to work with, to move over to that vacant Thursday 2 o'clock class. That is the dash group here, because we have lots of seats available there. So check your allocate timetable, turn up to your first class. They start this week. There's not a huge amount of content we cover, but we'll get the tutors to go over the assessments and all that sort of stuff. And the first lot of assessments aren't that far away, unfortunately, so it's important to probably turn up. Form your groups, that's the most important thing. So as you'll see in the coming slides, we have a bit of group work in this subject, so you need to form your groups early and make sure you've got people to work with for those assessments. Now, the one other difference really is because we don't have that second hour for the assessment week, like in the tutorials, what we instead have is you guys sit a multiple choice test, everyone basically sits it, and it's in a lecture theatre on Thursdays at 12 o'clock. So everyone in the subject comes in, we have an hour slot, but the test only takes half an hour, and you sit that multiple choice quiz at 12 o'clock. The only exception is going to be there's a few students who have a biochem clash in week 7, I believe. many of you have already been in touch with Steve Jones about that. So what we're going to do for you guys is organise an alternate time, most likely the following day on the Friday. So I've got a list of students who that's the case for. I'll send out an email in the next week or so with the details of when we can probably do that alternative test. If you don't hear from me, you think you're one of these students, then please email me. The same thing's actually true for probably I've seen around 8 to 10 students who are doing the HAB prac as well. So Lloyd will no doubt talk to you about that as well, and we'll organise something for you too. So don't stress, but if you haven't heard from me in the next week or so, send me an email and I'll sort it out. Okay, so we have 3 modules, same as last semester except the different topics. First module is respiratory system. Let's see if I can turn those. You can't really read that, can you? Let's turn these lights down a little bit. At least try to. Doesn't want to work? Okay. I apologise for the visuals. It looks really nice and clean on my screen, but the lights aren't turning off. Anyway, all of this stuff that I'm going through now, if it doesn't make sense or if I miss something, it's all in the subject guide, which is on the LMS. So if you log in LMS up the top, there's a subject guide. It has all of these details. So 3 modules. Respiration is module 1. That's the first 4 weeks. And then the next 3, so 5, 6 and 7, are the kidney or the renal system. And then we have the last module, which is the same weighting as the other one. They're all worth 1/3 of your mark, but it's actually 2 topics, so endocrine and gastrointestinal system. The assessments are the same as for PTA. Okay, the timing of them is a little bit different, but the format is pretty much the same. Okay, so we have an online test for each module, which is based on the online content only. So the online resources, so the first ones that are up there are all basically respiratory anatomy, and there's a few others coming up which are on diseases and whatnot. They'll be assessed in your online test. The multiple choice quiz, which is all of the lecture content, so not the online stuff, but so that will be in Thursdays 12 o'clock, unless you're one of those few students who has a clash. And then the final 2 are your short/long answer questions, which are actually you sit these assessments during your allocated workshops during weeks 4, 7 and 12. So all of these assessments, you have the same lot for each module, the same format, just different topics, week 4, week 7 and week 12. And we'll talk more about those last 2 in particular during your workshop this week. So for those dietetic students, I know you guys probably have no idea what I'm talking about right now. Your tutor will go through that in a bit more detail than I do. So collectively that makes up your full mark. So just to quickly go over this before John comes in. So your online test, okay, you sit that in an online format whenever you want. You only get 1 attempt. Opens Monday 9 o'clock of test week, so weeks 4, 7 and 12, and closes at Friday 5 o'clock. So it's up to you to do it whenever you want. And it has 10 multiple choice questions, and there's a big bank, so you don't all have the same test. The multiple choice quiz, so that's the lecture theatre. We have that in it should come up in your allocate timetable. That's in the Zental lecture theatre, which is over sort of towards YAG near the physical sciences buildings over there. And that will be focused on the lecture material, but be aware that there is a little bit of overlap with the online stuff. So for example, the online stuff that you've already covered, or should have already covered, is anatomy. Of course, you need to know a bit of anatomy to explain some physiology. So there is a little bit of overlap, but the focus of these assessments is the lectures. Case study tests, okay, same as last semester. So for those who are new to it, we have groups of 3, 4 or 5, so no groups of 2, no 6s. And we encourage you to form these groups this week. So start thinking about who you want to work with, who you can work with, and start practicing how you're going to work as a group for your assessment in week 4. So as I said, your tutor will go through that in more detail, but essentially you'll be submitting a group test at the end of, halfway through that test in week 4, 7 and 12. So there'll be 3 questions largely based on the case studies you've done in the prior 3 weeks, and you'll get a group mark. So everyone gets the same mark in the group regardless of how much they contribute. So we're really encouraging you to form your groups yourselves, work with people you think will be able to contribute and is going to turn up, and the onus is up to you to sort of make sure that you're happy with that. We're not going to be intervening with that too much. You guys are all old enough and ugly enough to sort that out. All right. So the only thing you have to do for the case study test, apart from contribute during the actual test, is the individual onus is up. We get you to submit a hurdle test prior to that actual case study, your class beginning. So you have to submit a hurdle test as per PTA last year. So it opens for a week. There's unlimited attempts. It's based on your case studies. So there'll be, again, a bank of questions. You won't get the same one each time. And you have to get 5 out of 5 before the close of that test. So they close actually on the Wednesday at 5 o'clock. So we'll be reminding you of this throughout the coming weeks, but please don't send me emails saying, oh, last semester it was at Thursday, 1 o'clock, I missed it. So you've got a whole 8 days to do it. Make sure you do it in time, and if you get 5 out of 5, then you'll get your group mark. It's easy. Extended response is a similar format to the group case study test, so they're obviously extended response questions, except you won't have as much to write. You only have about 1 page to do, and this will make up collectively 25% of your mark. So this will be based on the lecture material again, and you'll get an individual mark for this. Right, so pretty much everything I've said and some things I may have missed are all on the LMS. So the first thing to look at when you log in is have a look at the subject guide and the timetable. Have a look at your allocate system as well. Make sure you know which workshop you're going to. Make sure you turn up this week and start forming your groups. If you have any questions at all, if it's something you think the rest of the class may benefit from, please use the forum. There's 300 of you guys. You'd be amazed how many questions we get via email, which would save me a whole lot of time if I could just put it up on the forum. So particularly admin questions or physiology questions, post them to the forum so other people can see the answers to it. If you've got a personal question, obviously, then of course you can send an email. Now, on the LMS, you'll see there's a block for each module. Keep checking that every couple of days because we will be unveiling that as we go through semesters. So everything you need for this week is up. Hopefully in the next couple of days we'll put up the lecture notes for the next couple of weeks as well. So print off or have it on your laptop or whatever, the subject guide, the timetable, as well as there's a module guide. So for each module there's a little week by week list of things to do to check off and make sure you're up to date, as well as the lecture notes and of course the echo recordings and whatnot. We don't have an exam for this subject, which some people enjoy, some people don't. Hopefully the majority of you do enjoy it because pretty much you get through week 12 and you're done and then you can focus on your other subjects. But there are past exams on there, so they're up there for study purposes only. So when you get up to week 3 or 4 and you've got your assessments coming up, you can look at previous exam questions, and particularly they're the extended response ones there, so you can practice those. There's a few other things on there as well which I'm probably missing, but so get on there, have a look, make sure you're comfortable with the format of the subject. If there's any questions, post them on the forum or send me an email. And yeah, so that's what you need to have done this week. Okay, so have a look at those documents. As I said, the online learning objectives, the online content is available already, and ideally you would have watched prior to the first lecture today. Have a look at that. Turn up to your workshop on either Thursday or Friday, form your group, bring the case study material as well, so there is actually work to do this week, even though it's quite simple. And any questions, you can ask myself, or most likely your tutor will be able to answer it as well. So, yeah, that's all I've got to say. Is there any questions or any good timing? No questions? Okay, so we're going to start the content now. So most of you know John's going to give the first 4 weeks of lectures. So getting right into the respiration stuff straight away. So as I said, John's aware some of you haven't watched the online content so far, but if you can try and catch up after the lecture, that would be great. What was that, sorry? Yeah, sure. The computer took 10 minutes to load. That's why we're going, yeah.
Control already.
I can't get the lights.
Oh, and two of them.
We've got 2 on. Just records from that one, unfortunately. The light.
Which is a display.
So that's the one that records from. So I've turned the right one on as well, just because.
I'll turn the right one off.
Yeah, sure.
How do you do that?
Let's get a smile. Oh, doesn't seem to. What was that, sorry? It's true. It's true. I don't know.
What about all off?
I don't know. Yeah, I played around with it for a good 5 minutes. Could be that. I'm not sure.
Fair enough. Okay. Thanks, Stu. Okay, we might make a start for the content. Stuart said most of you might know who I am, but that's probably not the case because I've been away for 7 months on long service leave, travelling the world, but that's another story. So today's my first day back, in fact, so I apologise in advance if I'm a bit rusty. I haven't done this for about 10 months, but that's okay. Other than travelling for 7 months, which is important and interesting to me, but not for you, what other things can I tell you about myself? My name's Johannes, or John. I go by John Scayers, Associate Professor in Physiology. I'm also head of the Department of Physiology, Anatomy and Microbiology. So most of my job is an administrative job, running the departments, of which Stuart is part, and these subjects are a very important part of. But I also like to give lectures because, in fact, that's why I took the job in the first place. The communication with students is interesting and important. So this is my sort of foray into giving lectures this year. Normally in semester 1, I would have given the lectures on the nervous system and coordinated the PTA subject, but I didn't this year for obvious reasons. But I'm giving the lectures on respiration, which take up 8 lectures. Now, I might just shut that door if that's okay. So we're not interrupting the people outside. So there are 8 lectures, but as Stuart might have already said, 2 of those lectures are clicker sessions. Now, most of you, but not all of you, I'm familiar, did PTA, so you'll be familiar with clicker sessions. We have clicker sessions set in lecture 4 and 8 from memory. So happy for you to also give me feedback as to what sort of things you'd like us to revisit in those clicker sessions. I have my own set of questions, but happy to talk with you, or for you to let me know what you would like me to explain further or again in those sessions. So happy for them to be interactive. That leaves 6 content lectures, so it affords us a nice opportunity to go at a nice steady pace. So I'm happy for you to slow me down or speed me up, as the case may be, for any content that we deliver in these lectures. So happy to pause for questions whenever you have any. The other thing is that there are some online lectures or information that normally, should not this be the first lecture of the semester, we would have thought you might have looked at, as Stuart said when I arrived, an awareness that not everybody has looked at the online material related to respiration. The online material related to respiration that's relevant for today's lecture really covers the structure and function. And so what I'll do is spend a couple of minutes going through that content just to make sure that if I launch straight into things that were predicated by your knowledge of structure and function, I might lose a significant proportion of the audience. So I'll cover it fairly quickly by detail. Having said that, I will rush through this, so if you're concerned about the speed at which I'm going, just be aware that all the material is covered in much more detail in the online components, so it's not as if this is the first and only time you listen to it. The other things I should say is that Stuart and Tanya, Stuart for this subject, Tanya for the previous subject, have changed textbooks. Now, I I know this is sometimes a sense of frustration, but what I've tried to do is use the textbook, the images from Silverthorne. Sometimes Silverthorne's lectures are terrific. Sometimes Silverthorne's pictures are terrific for a textbook. They're not that terrific to show in a lecture because there might be a lot of detail, a lot of words, a lot of small imagery, which is great if you're looking at it in front of you, but not great if you've got a lecture and you're trying to tease through it. So where I've used diagrams that aren't Silverthorne's, it's not because I'm being contrary or anything, it's just that I do believe that I'll use the best image available from a variety of textbooks, but I'll always reference a similar image in Silverthorne, should there be one. So I will give you the reference in Silverthorne for the image that's relevant to the diagram I'm showing, if that makes it a bit easier and better. And similarly, there was something else I was going to say about that. Can't remember. Oh, that's right. That given that some of the diagrams are not in Silverthorne, it's the reason that I provided Stuart with one slide per page online data, as well as 3 per page. So if you are worried about a diagram, they should all be in your LMS, single diagrams per page as well. Yep. Probably. Probably, I think so. Okay. So you want them presented as landscape rather than portrait. Okay. I'll see whether that can be done. I'm not sure. I'll try it, and if it is, I'll certainly do it. Easy. Doesn't take too long. Enough of that. Let's go through the content. Respiration. I always find respiration one of the more interesting body systems because it all kind of makes sense. There's nothing that's random about the respiratory system. Everything's there for a reason, and it all interrelates. Sometimes it's a bit challenging because there's a lot of numbers that you need to be familiar with, and it's kind of, there will be some numbers you'll have to recall to make sure you memorise, and there's no getting around that, but I'll tell you where those are relevant. Also, given that a lot of the data, or some of the data, particularly early on, relates to a typical average human, and there is no such thing as a typical average human, you'll find some of the numbers in different textbooks vary slightly. Now, don't let that be a concern to you. Certainly none of my questions are going to say there are, 500 million alveoli in a human, or 450 million, or 495 million. I mean, it could be all of the above. So you're not going to get that level of questioning. So don't worry about the fact that some of the numbers vary slightly between different textbooks. They just use an average number. Okay, so just, if you're going to be concerned, don't. The lights are on, and Stuart told me you can't dim the lights, so I apologise that some of the imagery is less clear than it might be because there's too much illumination at the front of the room, but we'll soldier on. This looks at a representation of the respiratory system. And it's divided into upper and lower respiratory systems, not only based on the anatomy, but also some functionality. Those components that form part of the upper respiratory system often have dual purpose. So they're not only there in us to allow us to breathe and gas exchange. And they include the nasal and oral cavities, the pharynx, and the larynx. I'll go through very briefly their function in a minute. The lower respiratory system is not only anatomically inferior, position-wise, but also is exclusive to the respiratory system. That is, its only function is to allow you to breathe and to gas exchange or respirate. And they include the trachea, which some people call the windpipe. I'd prefer not to. The trachea is its appropriate anatomical term. and the smaller structures which are extensions of the trachea, which include the bronchi and bronchioles, and ultimately the alveoli. And we'll go through those very rapidly, but they're more detailed online. So what are some of the functions? Very quickly. Humans are somewhat different from most other organisms in that we have the choice of breathing through two apertures, the nasal cavity or the oral cavity. Now, some other animals can do that, many can't. And you might say, well, why do we have those two options? And in fact, what is the preferred option? Does anyone kind of hazard a guess or know what the preferred option is of either breathing through the nose or breathing through the mouth? What are we particularly designed to do? Breathe through the nose. And the reason for that is, as you can see, it's quite a large cavity. Even though the apertures, the nostrils, are fairly small, the cavity further on is quite large. It also has these cartilaginous plates, which you can see here. They're not labelled, they don't need to be. They are in my online presentation. I feel like I'm spruiking for something, but I'm not. You can see here these cartilaginous plates, or I hope you can see the cartilaginous plates, which run perpendicular to the wall, and they're called the nasal conchae for whatever reason. And they have a very important structure. What they do is that they create a turbulence and hence slow down the movement of air through the nasal cavity. Why do you want to slow down the air? Because there are two things that the nasal cavity will do, particularly effective, and needs a little bit of time to do. Now, we're not talking about slowing it down by seconds. We're talking about milliseconds, but it's still effective. We want to warm the air. And where does the body get most of its heat from? Which structure in the human body is basically our core temperature. When you talk about somebody's core temperature, what are we measuring the temperature of? Blood, well done, the blood. So if you want to warm the air, what must the nasal cavity have a very good supply of? Blood. So there are lots of capillaries in the nasal conchae, allowing you to heat the air. Now, I could talk forever, and I shouldn't, but it's often why in cold temperatures and with any inflammation you get frequent nosebleeds, or some people are predisposed to them because of this quite large amount of capillary exchange that occurs in this region. The other thing you want to do to the air is humidify it. And the nasal cavity is lined with liquid. And so moving air very rapidly through this region humidifies the air. Now, why do we want the air to be humid and warm? Because, I'm answering my own questions, and that's fine. Because many of the airways are made up of smooth muscle. And what's one of the biggest stimuli for contraction and hence narrowing of the tubes of smooth muscle? Temperature, cold. You stick your hand in a bucket of cold water, what happens to the blood vessels? They constrict, because temperature directly stimulates contraction and constriction if we're talking about a tube of smooth muscle. So we want the air to be warm, we want the air to be humid.
In situations where the temperature is hot, say over 40 degrees, does this serve to cool the air as effectively?
It can cool the air because what we're trying to do is keep the air temperature as close to possible to the blood temperature. So you're right. And it's also when you breathe out, you tend to recapture a lot of that heat as well. So we're not wasting that heat. The other thing the nasal cavity does, and again, I'm spending too much time on it because it's kind of interesting, well, I think so anyway, is that we also have these immune cells that line the back of the nasal cavity, particularly where the nasal cavity becomes the pharynx. There are these immune cells called the pharyngeal tonsils, and they exude mucus, which traps particulate matter And again, I know I'm going to go through this quickly, but it's all online. You breathe in, the air has to do a right angle turn. Now, particulate matter, that is dust and heavy particles, won't be able to turn as effectively as the air molecules. So they'll just hit the back of the throat. They'll stick to the mucus, the pharyngeal tonsils will release their immune cells, and you'll destroy a lot of that particulate matter and bacteria and virus or whatever happens to be there. And that's beneficial. Yep. It's not recording. It says it's recording here. Yeah? No? So, okay, you've got a screen, have you? My screen says it's recording, so hopefully one's right and hopefully this one. Thanks for the alert anyway. The other thing is that what's the limitation then? They're the positives. Why bother have a mouth then? Well, when do you tend to breathe through the mouth? When your nose is blocked, and that happens, you get an overproduction of mucus, but also when you are exercising. You tend to breathe through your mouth because the limitation of breathing through the nose, the nasal cavity or the nostrils are small, big resistance to large movements of air. So when you want to get large volumes of air in and out of the lungs quickly, you breathe through the mouth, bigger opening, less resistance. That's the story. Pharynx, what's its function? Immune function, as I said. Other than that, not really a big function to breathing and respiration. By the way, there is a definition online. Breathing is ventilation, the movement of air in and out of the lungs. Respiration is gas exchange. So I'll be using those terms accurately. So if you do get confused what they mean, online definition. And the larynx, again, in terms of ventilation or breathing, not a big function. Lots of function in terms of speech, but that's not what these lectures are all about. Then the air gets to the trachea, which is a tube, standalone tube for breathing or ventilation only. You can see here, large tube, couple of centimetre diameter, cartilaginous rings. Why do you think we've got cartilaginous rings here? Yeah, stops the airways, the trachea from collapsing because it's smooth muscle otherwise. So it keeps the airways open, less resistance to movement of air. When the trachea get to a certain region, we cover that online, it bifurcates or divides into two. Bifurcation, fancy word, dividing into two. At that point, we no longer call it a trachea, we call it bronchi. Plural, bronchus singular, but there's more than one, so bronchi plural. The bronchi have a smaller diameter. They then divide into two. Smaller again, they divide into two, smaller again, you get the picture. That happens 23 times, 23 generations. Now, the general guide is that each one divides into two. Look, sometimes they divide into three, let's not get too hung up about it. But you can see the idea that there's lots and lots of divisions, they get smaller and smaller, but the benefit is that you increase the surface area dramatically as you divide them further and further. At some point, the airways become so small that they no longer can have cartilaginous rings. It's counterproductive. And the only relevance to you and I is the name. We don't no longer call these airways bronchi, we call them bronchioles, small bronchi. So the difference between bronchi and bronchioles has no cartilage. They then are prone to collapse, which becomes relevant in another lecture. And then right at the end, there has to be an end point. It's not like the circulatory system, which is a continuous cycle. It finishes at a point, and that point are the alveoli, of which there would be, which are balloon-shaped structures. What's the benefit of the structures being balloon shape? Biggest surface area per volume you can get is a sphere, so great adaptation. We have so many alveoli, as I said earlier, there's probably about, and again memorising, about 500 million alveoli. So you can imagine the huge surface area we have, and the textbooks will tell you it's about 70 metres squared. which is probably not much different from the size of this lecture theatre, that's the surface area you have in your lungs, particularly designed to promote gas exchange or respiration. Both lungs combined, yeah. We tend to use them as collectively because the left and right lung functionally have no difference. So we tend to speak collectively. So look, random numbers, don't have to remember them, but it just sort of throws me, it just reminds me of the complexity and design of this feature. We've got about 2,500 kilometres of airways leading into 500 million alveoli with a surface area of 70 square metres on average. So it just gives you an idea of how important and physically adapted we are for gas exchange. They were my numbers I had to remember off by heart. Now I'm in cruise control. Damn it. But I'm not in cruise control because I'm going far too slowly, so let's move on. The other thing we have, and again this is online, I'm getting to the new stuff in a second, we have a conducting zone, because I gave you two definitions before. Ventilation or breathing, function, get air into and out of the alveoli. Second definition, respiration, gas exchange, exchange oxygen and carbon dioxide, which is after all why we have a respiratory system. The conducting zone's primary function is for breathing or ventilation, getting the air to the alveoli, and hence the conducting zone consists of the nasal or oral cavities, the pharynx, larynx, trachea, bronchi and bronchioles. They don't gas exchange. They only deliver the air to the alveoli. Because they don't gas exchange, we tend to refer to the volume inside them at any given time as the dead space. And I apologise, the lights are making that red writing not very clear. It will be clear in your lecture notes. But we can't turn the lights off, I'm afraid. But the dead space has an average volume of about 150 mils. So at any one time, there is 150 mils of air in the conducting zone which does not participate in gas exchange. The relevance of that is critically important, but not right now. We'll get to it. The rest of the air you breathe does get to the structures of gas exchange, and they're called the respiratory zones, highlighted by this diagram I've adapted from Silverthorne, chapter 17.2. And it shows the very ends of these airways, which are called the respiratory bronchioles, the alveolar ducts, which are kind of like the stalks of the grapes, and the grapes themselves, or the alveoli, which is where all the gas exchange occurs. Some summary information. Every lecture from now on, I will start with very simple phrases, which basically gives you an idea of what I'm going to do in the rest of the lecture, or for that lecture, for the rest of today's lecture. So, we've got the anatomy out of the way, or reviewed it from the online material. This is new information, and we're going to look at the mechanics of breathing or ventilation. So, 3 summary statements that will basically encapsulate what we'll do in today's and tomorrow's lecture. Pulmonary ventilation, remember ventilation is another word for breathing, is the exchange of air between the atmosphere and lungs. So our job is to get this stuff in the atmosphere into the alveoli, because otherwise it's not going to work. How do we get this stuff into and out of the lungs? Well, that's what we're going to do, but the take-home message, the spoiler, is that air, like most things, moves down pressure gradients. So as you'll see, we create the pressure gradient, air will then flow down that gradient. You will see that breathing in and breathing out, obviously very closely related but different, in that inspiration or breathing in is an active process. When we talk about active in physiology, what kind of things does that make you think of? It requires work and energy. So it requires energy in the form of ATP and action potentials, and uses muscles. Whereas expiration or quiet expiration is passive. It relies not on energy. It doesn't require energy, normal breathing out. Forced expiration does. And it relies on things that we'll talk about through these lectures: elasticity, the lungs' elasticity, and surface tension. And that's how we breathe out. Let's look at that in much more detail now. So that was the summary. Before we do all that, we need to understand something about a molecule called surfactant. So I'm going to introduce you, or reacquaint you with, if you did first year physiology, a molecule called surfactant. And there's some notes up here telling you about them. Basically, I'm going to set the scenario where we have a problem. The problem is the surface of our alveoli, and remember there's 500 million of these little fellas, and they're very small, but the surface is lined with water. Why? Because gas exchange will not occur across a dry surface. In fact, no diffusion occurs effectively across a dry surface. So if we want to diffuse gases across our alveoli into the blood, it needs to be wet. Perfect. Produce liquid, breathe in liquid, humidify our air, that'll create the liquid. Problem solved. That problem solved, but we generate another one. Water molecules are very strongly cohesive. And the textbooks and everyone talks about this in the same example. You know, get 2 plates of glass or 2 glasses together, wet them, stick them together, and try and pull them apart. It is nearly impossible to do so. Water molecules have such strong cohesive forces that to counter that forces requires a huge amount of energy. So by making our alveoli moist, we solve the problem of gas exchange, but we cause a problem that we're not going to be able to inflate our alveoli because we won't be strong enough to do so. So how do we get over the problem that we've created by making these alveoli moist? Well, have cells in the alveoli that produce a chemical called surfactant. Surfactant's produced by these type 2 cells online. You'll learn about it, which is like a phospholipid or a detergent. Now, if you add detergent to water, it weakens cohesive forces between the water molecules. That's what detergent does. And so you and I produce surfactant, which weakens but not totally abolishes the cohesive forces between these water molecules, thus allowing us to inflate our alveoli and our lungs. So that's why we have surfactant and why it's very important. Now, just a very couple of quick words about surfactant before we leave to put a clinical consequence on it. One of the biggest problems with premature babies is if they're born too early, they haven't produced surfactant yet, and therefore the cohesive forces of the water molecules are too great, and they physically won't be able to inflate their alveoli. And that's why the biggest cause of death for premature babies is respiratory distress caused by lack of surfactant. The other thing, aged people. Some people, as they get older, don't produce sufficient surfactant for lots of reasons, be it a consequence of being a heavy smoker, whatever. And again, it can be a problem with some aged individuals. For most of us, it's not a problem, but we do find that every now and again, and this is just one of those quirky stories, I should stop them because they waste time, but we probably don't even notice, but about every 10th, and it's not like a metronome every 10th breath, but about one in every 10 breaths we take tends to be bigger than the others. And we've worked out that the reason that occurs is that overinflation of the lungs tends to stimulate these cells to produce surfactant. So you and I are stimulating the production of surfactant without even thinking about it throughout our lives. But where that becomes relevant is that if any of you go on and work clinically, some of you might, with patients who have an injury to their ribs or they're older people, it's one of the reasons, not the only reason, but one of the reasons it's important to get these people to breathe deeply, because you need to encourage the constant production of surfactant. So that's one of the reasons it happens, if you've ever heard of it. Surfactant has another very important role, and this comes down to somebody called Laplace, which I used to call Laplace, but the P now has become capitalised, I've noticed over the years, so it's now Laplace's law, which relates pressure to tension and size. Now, the law itself is fairly simple. The relevance of it is a little more complicated, but we'll go through it quickly. This is the other reason we have surfactant. Other than weakening the water bonds, allowing us to inflate our alveoli, we have surfactant because it overcomes the issue generated by Laplace's law. The pressure inside an alveolus, or anything, is equal to 2 times the tension divided by the radius. Now, you're probably thinking, yeah, you've lost me already. That's okay, I'll get you back again in a minute. If we look at our alveoli on the left, and I've taken this diagram from Widmeyer, but Silverthorne has a not as good diagram for this purpose, so that's why I've referenced both, but this diagram is a better diagram. It comes from Widmeyer. Nevertheless, you know how I said we had 500 million of these alveoli? They are not identical. Some of them are smaller than others, or some are bigger than others, obviously. Now, that creates a problem. Why? Because Laplace's law tells us that the radius affects the pressure. So let's look at a big alveolus and a small alveolus, and they're all interconnected. They have to be, because they're all connected via these little alveolar ducts to our bronchioles, to the bronchi, to the trachea, to the atmosphere. So, which one's going to have the biggest pressure? Well, Laplace's law says that, in fact, if the pressure equals the surface tension divided by the radius, and if the surface tension of both alveoli were the same in this example, the pressure inside the larger alveoli would be smaller because it has a bigger radius. Okay? A bigger number down the bottom means that the pressure is going to be smaller. Now, what would happen if all your bigger alveoli had a lower pressure than your smaller ones, and they're connected? All the air is going to be sucked into the big alveoli. And what will happen, instead of having 500 million alveoli with huge surface area, you'll end up having one big alveolus. Okay, so we don't want that. So how do we stop that from happening? Well, on the right-hand side, what we do is we produce surfactant. And we produce it proportionally. So our alveoli are, and I know I'm apomorphizing this situation, they don't have their own brains, but it works for my story. The alveoli produce sufficient surfactant to ensure, irrespective of its size, it will have the same pressure as its neighbour. So different sized alveoli produce different amounts of surfactant, making sure that the surface tension in the larger alveoli will be larger than the surface, proportionally larger than the surface tension in the smaller alveoli, which means if you key it into Laplace's law, the pressures will be equal. And that's really, even if you didn't understand the steps, the take-home message is, the second important thing about surfactant, it means that our alveolar pressures are the same throughout the body, throughout the lungs, irrespective of their size. Really important. Let's talk about inspiration and expiration, and I'm running out of time, I'm aware of that. So what I'll do is that I'll